Hi, I am Nitisaran. Here we are going to explain about system calls in operating systems and in-depth exploration. Contents. There are three main contents in that. First, introduction to system calls. Second, types of system calls. Third, system calls implementation. First, introduction to system calls. Definition and purpose. What are system calls? System calls are programming interfaces that allows user application to request services from the operating system's kernels, facilitating interactions between the user programs and the underlying hardware. The role in system operation. System calls play a crucial role in managing system resources and executing processes, ensuring that user application can perform tasks like files management and process control. Key concepts. User space versus kernel space. User space is where user application reside, while kernel space is reserved for the operating system core. They are separating enhances security and stability by preventing user programs from directly accessing critical system resources. Context switching. Context switching is the process of storing and restoring the state of the CPU so that multiple processes can share the CPU resources efficiently, ensuring that they each receive processor time and maintaining system responsiveness. Second, types of system calls. Process control calls. Creating and terminating processes. Creating process involves allocating necessary system resources and initiating process control blocks. Terminating process releases resources and can signal other processes about completion. Process synchronization. Process synchronization ensures multiple processes can operate smoothly without conflicts. Includes mechanisms like semaphores and mutex to manage access to shared resources. Process control system calls manage processes in operating system, allowing processes to be created, executed, terminated, and synchronized. Explanation of process control calls with examples. For process creation, create a child process, duplication of parent process, returns 0 to the child process, PID of the child to the parent process, negative -1 on failure. Wait process synchronization makes a parent process wait until its child finishes execution, prevents zombie process terminated but not removed from the memory. Exit process termination terminates the process and returns an exit status to the OS. Kill sending signals sends a signal to process, usually to terminate it. Example, kill -9 PID in Linux. Possibility kills a process. Nice process priority control changes the priority of a process. Lower values is equal to higher priority, higher values is equal to lower priority. Conclusion. Process control system calls enable efficient process management in operating system. They help in creating, executing, terminating, and synchronizing processes. And one more process, that name is XX, process execution, replaces the current process with a new program used after fork to run a different program in the child process. File management calls. File operations, open, read, write. File operations allows program to interact with files, enabling them to open files for accessing, read data, and write new information. These calls manage file permission and data integrity. Directory operations. Directory operations manage the creation, deletion, and organization of files within directories. This allows user and application to navigate and maintain the hierarchy structure of the file systems. Third, system call implementation. Mechanisms of innovation. System call interface. The system call interface acts as the bridge between user application and the operating system, enabling programs to request services by transition from user mode to kernel mode securely. Handling interrupts and traps. Interrupts and traps are mechanisms for directing the CPU to halt current process, enabling the operating system to handle exception or special events through defined routines, ensuring system stability. Performance consideration. Overhead in system calls. System calls inherently carry overhead due to the need for mode switching and context saving, which can impact performance if invoked too frequently in applications, leading to inefficiency. Strategies for optimization. Optimizing system calls can be achieved through methods like reducing frequency of calls using async processing or leveraging more efficient syscalls APIs, which helps to improve overall system responsiveness and throughput. Mechanism of invocation. In an operating system, an invocation mechanism refers to the way processes request services from the OS or communicate with each other. These mechanisms allow programs to execute privileged operations like accessing hardware, managing memory, or interacting with other processes. Types of invocation mechanisms: system calls, interrupts, message passing, remote procedure calls, signals, traps, and exception. Traps and exception handle expected conditions like a division by zero or invalid memory access. Types: traps, initial system calls; exception, unintentional. Second type, signals. Signals are software notifications sent to process for event handling. Example, termination alarms. Third, remote procedure calls. Remote procedure calls allows a program to call a function on a remote mechanism as if it were local. Steps in remote procedure calls. Client process sends a request to the server. Server executes the requested function. Response is sent back to the client. Fourth, message passing. Process communicate by sending and receiving messages used in distributed systems and microkernels. Thanks.